So we'll talk about the level 3 fabrication. This year for the level 3s, we decided to do a 100-ton all-terrain crane. If you watched our previous videos, we did the train and the train car. We decided to up it a notch, let's say, and a notch. We went a little bit bigger. It was an ambitious project, but for 6.5 weeks, the students did a fantastic job, from simple blueprints to upgraded blueprints to just innovative ways of being able to do stuff. The crane itself rotates, it rolls, the boom extends. So like, for example, when we come into this position, if we push this, we can actually take the crane block off. And so we have one extension, only one, because it was getting a little too big. So when we bring it out, we have about a 7-foot extension that comes out. The boom itself will raise to about, say, 30, 35 degrees, and it gets pinned. So this one will actually get pinned in the main hydraulic here. Once we raise it, it'll pin itself as well. So it'll stay in an upright position with the extension out. The crane itself will rotate. We did grease everything, and we have it so that it's not on a bearing or anything. It's just steel on steel, but we put some grease on it so that we can actually spin it. And we have a preset pin hole in the bottom here, but we can rotate and slide the pin through at a 30 degree to keep it from, well, tipping over. The idea is to eventually bring it out front, bring the boom up, turn the crane slightly, and have the crane up on the outrigger. So the outriggers on all 4 sides work. So if you come to the outrigger, it does slide out. And then once we raise it up, we'll be able to put the pads down. So I believe we can come up about 6 inches off the ground with it. So the students designed the whole systems for the outriggers that actually fit within the frame. If we went back, if we were to take it all apart, if you look at some of the pictures that we'll be posting online, there's a whole chassis, subframe. The wheels themselves, we put extra detail into the wheels. They have treads on them, which gives them a more realistic look. But there's a hub that they're connected to, and the 4 sets actually will rotate with each other. So they're all linkaged in. So the back set, once it's up, you can turn all 4 with just by turning one wheel. Same with the front. Aluminum is all pre-drilled so that we can paint it, which is the next step, and then the aluminum will be put back on and we'll rivet it down. So the doors all open too. We had hoped to get to a point to be able to do inside the cabs, but 6.5 weeks was pushing it with the amount of work that we did here. Even there's a hidden latch even underneath here to be able to open the front door. They're down. So the students did a fantastic job. There was so much detail put into this, and meticulously. It was run the same way. If you watch previous videos on the train, it was run with 2 companies. So we split the students down the middle, and they had to run 2 companies. Everybody had to rotate through the job roles. Everybody had a hand in blueprinting. Everybody had a hand in tracking material cost, employee wages, because they had preset budgets. Health and safety was a new component we added to it so that everybody had a hand in that. We even had co-op students helping and hiring them in as contractors, so they had to account for them in their budget as well. So it was it's very much evolved from where it started with the train into something like this, and it turned out fantastic. I'm very proud of the students. They did a great job. I'd love to take it home and put it on my lawn. That's not going to happen.
Can I get you to show me the hook?
Oh, the hook. So we wanted to make a hook, but obviously we're not going to run and buy a bunch of cable for it. So it will turn in here, but we have it preset the specific distance, and even the hook itself, or the block and the hook, it all spins so that it'll connect in. So when we lock it all in and we move it, it'll be hooked on the front. This way we have some distance on the cable so that when we raise the boom, we could possibly hang something, a very nice big APR sign on it or something. But yes, so the next project I hope to be even bigger. Don't tell them that. As long as it fits out the door. That's what I was told.
I regret my decision. How long is this now, Andrew?
I believe we're pushing, or we're around 25 feet with the extension out on it. I guess we should, instead of guesstimating, we'll take a tape measure and try this out.
Is the tape long enough?
What are we at right there?
So we're at about 286 inches, which is 23 feet, 10 inches.
Oh, so I was a little shy of what I thought it was, but that's all right. I could have made it bigger. Next time. For challenge-wise, it posed quite a bit of challenges for the students in some areas because they had to rethink how they would actually have to do it. And it's nice because every piece of equipment in the shop was used to help make this, from the shear to the brake to the rolls. Everything is hand cut with plasma or zip disc. So even though everybody wanted to use the water jet, they could not use the water jet. It kind of speaks for itself, because we see it all the time. We're here, we're working on it, the students were seeing it, but when you actually step back from it and you look at it, it is quite fantastic, because it was only 1/8 flat steel at one point, and now we have a fully three-dimensional crane that actually rolls, turns, moves. I'm sure it'll lift something if we figured some way of doing it, but
how many sheets of 1/8?
It was 22 sheets of 1/8 4x8, 3 24-foot long pieces of 3x3 HSS. There was some 2.5 by 2.5 HSS, untold lengths of 1x1 1/8 angle and 1x1 1/8 square tubing as well. And then many spools of wire, a lot of grinding discs, a lot of zip discs, flapper discs. We went through a tremendous amount.
Yep.
It was an interesting exercise in what we could actually accomplish if everybody has the same mindset to get the job done, and everybody was on board with doing it, because how often you get to do something like this, right? So it's whatever to get them out of the booth, get them working on something that's real world applicable to a degree. Like, not many people get to work on a crane, but they sure did.